All right, so here is our last and final guided practice for specific heat. So here we go. We're going to label everything like we have been. I want to know, what is the final temperature? There's my question word, what? So this will be T final of a 91.0 gram sample. Grams measures mass. Piece of copper with an initial temperature of 20 degrees Celsius. This is my Ti. After it absorbed 1,581 joules of heat. So this is my Q. And let me point out that it says that we absorbed heat. Remember, when we absorb heat, that is an endothermic reaction. So that must be a positive Q. It said that we released the heat, we would have to make this Q negative, right? Keep that in mind because they won't always put this as a negative number, right? And copper has a specific heat of this. So that is my C. All right. So I want to give you one tip for these types of problems. If you are looking for the T final, do not change the initial temperature from Celsius to Kelvin. It will mess up your equation. This is the only time I am telling you not to change your temperature, is if you are looking for T final. So I'm going to go ahead, I'm going to write that up here, right? So do not change Ti from degrees Celsius to Kelvin when you're looking for TF, all right? That is key. Do not do it. Leave it alone. And this is the only time I'm telling you to do it, all right? I'm trying to make your life just a little bit easier. So I want to go ahead. We're going to write down our equation. The equation is Q equals MC delta T. Again, always start by finding delta T. So our delta T is equal to T final minus T initial. So we're going to go ahead and we can plug in what we know, right? The delta T is equal to T final. But look, that's what I'm looking for. So again, if I'm looking for it, it's got to be X minus the T initial, which is 20. So this is what I'm going to use to plug into my equation, all right? So let's do that. So plug in our numbers now. Q, so in place of Q, we have 1,581. Remember, it is positive because we absorbed heat, so it must be positive, right? Equals my M, which is 91, my C, which is 0.386, and then my delta T, which is X minus 20. All right, so there it is. All right. So here is the goal. The goal is this X minus 20. It's in parentheses, right? So this is like its little box on its own. I want to try to get this by itself on one side of the equation. So here we're going to simplify what we can. So I have 1,581, right? I cannot plug this into the calculator and do anything else. I can, but if I push enter, I'm going to get the same number. So I'm just going to write it over again. Equals, I want to simplify this. I can combine those terms in the calculator. So I can go ahead and I can multiply these two numbers together. When you do that, you get 35.126. right? And I cannot put X into our calculators, and you cannot do it at home either on your phone. So what we're going to do is we're going to just keep it like that, right? So again, I told you our job is to get this by itself. So in order to get this by itself, I need to get rid of this section right here. So right now, x minus 20 is being multiplied by this number. So in order to get rid of this number, we must do the opposite of multiplication, which is division. So 35.126. What you do to one side, you must do to the other side. Okay. Now these two numbers cancel each other out, right? You are going to put into your calculators 1,581 goes on top. It's on top, it's first, divided by 35.126, and you should get 45.009. And I rounded, equals, I still have this x minus 20 right here. So x minus 20. All right. Now we need to go ahead and we move the 20 over here, right? We gotta get x by itself. So x minus 20, to get rid of the minus 20, we gotta do the opposite of subtraction, which is addition. So plus 20 here and plus 20 here. These cancel out. And you get x equals, and if I round to two significant figures, 65, and it was my temperature, right? So it was degrees Celsius, because my initial temperature is Celsius. So I want to keep it Celsius this time, and only this time. We always want to go to Kelvin. If they give us both temperatures, change it to Kelvin. Or if we're doing gas laws, it must stay in Kelvin. This is the only time we do not change it, right? So that is the end of your guided practice for enthalpy. Remember, your mass or even your specific heat could be X. And if so, you would solve it by doing some division, right? If you have any questions, please do not hesitate to contact me on the Google Classroom. And I can also set up a video chat with you if you need some more help or some more practice. Just let us know.